All right, hello IB. We're going to go ahead and jump into sign diagrams. And we have talked a little bit about sign diagrams already. However, now we're going to get down to the nitty gritty and find out all the details that we need to accurately draw a sign diagram and figure out what it actually tells us about our graph. So a few basic steps. You should write down these 3 steps because we'll use them every time that we draw a sign diagram or that we use a sign diagram. We want to draw the number line, which is what we use for our sign diagram, and it represents your x-axis. So we'll draw a line, and that will be our number line that's representing the x-axis, and that's where we'll plot our critical points. So in order to plot our critical points, we need to find our critical points, and basically, once we find our critical points, and we'll talk about what exactly those are in a moment, we use a solid line for any x-intercepts, so note that. And then for any asymptotes, we will wind up using a dotted line just because those aren't actually points on our graph, but they are restrictions that we need to be aware of. So our x-intercepts will be represented by solid lines, and then our asymptotes by dotted lines. So again, those are 2 types of critical values, finding our x-intercepts and finding our asymptotes. And we'll talk more about those in a moment. And then third, once you have your x-intercepts and your asymptotes marked on your number line, we're going to use some test values in the intervals. So remember, we were using a number line just a few days ago when we were trying to figure out solutions for quadratic inequalities. So let's say we have an x-intercept at -1, and then let's say we have another x-intercept at 2, and then let's say we might have, I don't know, an asymptote at 3. Okay, whatever the case is, we're going to choose a test value somewhere in this interval from -infinity up to -1. And if you test that value, substitute it into your function, and it comes out to be a positive y value, that means that your function has a positive value. So that's where we would put a plus sign there. Whereas if you substitute in a value, let's say between -1 and 2, in this interval, and we substitute back into our function, and it gives us a negative value, then we'll write down a minus sign to represent that our function is negative in that interval. Let's actually see how this works when we compare it to an actual function. So looking at these 3 examples, you'll notice that the first function is written, it's a quadratic, written in factored form, and automatically we see that we have an x-intercept at -2 and at +1. So automatically those 2 values are written down on our sign diagram. So again, this line is representing your x-axis. We have a critical value at -2, and we have a critical value at +1. And then we're using test values, so we could choose like -3 in this first interval from -infinity up to -2. And if we take -3, substitute it back into our function, what the sign diagram is telling us is that we come out with a positive value. If I choose a number between -2 and +1, and I substitute it back into my function, I get a negative value. And if I choose a value after 1, so 2, 3, 4, anything positive above 1, substitute back into our function, I have a positive value. And notice how that corresponds with our graph. So below -2, you have this part of your graph, which is above the x-axis, so your y value is positive. Between -2 and 1, you have negative values, they're below the x-axis. And then from 1 to infinity, you have this part of your graph, which is above your x-axis, so they're positive y values, which just means your function is positive. Also notice that your exponents on your factors are a 1. So what we'll start to see a trend here with is that if your factors have an odd degree, where 1 is an odd number, so it's an odd degree, you'll notice that you cross your x-axis at that point. So at -2, we actually do cross our x-axis. So we go from having positive y values to negative y values. If you look at the second example, we have an x-intercept at +1, so we only use +1 on our sign diagram. However, notice that our degree is an even number of 2. So if we have an even number of 2 as our degree, We bounce off the x-axis. That's where you guys have your double root. And notice your signs do not change. So the more that we pick up on these patterns, the easier it will be for us to check our work, and we can also do it a little quicker and more efficiently if we see these patterns when we're actually working through a question. And then our last example, we don't have an x-intercept, but we do have an asymptote. So we have an asymptote at x equals 0, and we also have an asymptote at y equals 0, but we only write down our vertical asymptotes. So in your sign diagram, because we're talking about x values, we write down your vertical asymptotes, not your horizontal ones, and we have a vertical asymptote at 0. So if we take a test value below 0, we'll get a negative y value, and if we take a test value above 0, we get a positive y value. So that helps us to figure out where our graph is going to curve for this rational function. And rational functions are going to come in, we'll be working on those in more detail in the next few days. So just to summarize what we just spoke about, if you fully factor a quadratic and set your y equal to 0 to find your x-intercepts, you'll notice that if you have an odd power, then the curve actually cuts through the x-axis. So that was, for example, here in this first problem. We had odd powers of 1, and we noticed that the graph actually cuts across the x-axis at those values. Whereas when you have an even power, that was in our second example right here, okay, you'll notice that we touch the x-axis, but we bounce off of it. We have a double root there, and we do not have a sign change. So we stayed negative in both intervals. So let's look at this example then. You can welcome to pause the video and try this one on your own. But you'll notice already we have an odd power for x minus 4. So we should cut the x-axis at 4. So we should see a sign change there. And then with x plus 2 squared, we have an even power. So we should notice that we just touch the x-axis, but we don't actually have a sign change. So if we are going to go ahead and find our x-intercepts, we'll set x minus 4 equal to 0. So again, we already know we're going to have x equals 4 as one critical value. And then x plus 2 equals 0. So we already know we're going to have x equals negative 2. So let's go ahead and put both of those values, negative 2 and positive 4, on our number line to make our sign diagram. Let's choose a value below negative 2. So let's say I choose a test value of negative 3. So I'll just write it up here so I know what I substituted in. And if I take negative 3, and I'm going to substitute negative 3 into my function. Now notice, if I have x plus 2 squared, that's always going to come out to be positive. So I'm really only concerned about this first factor. So negative 3 minus 4 is negative 7. My second factor is always going to come out positive. So negative 7 is going to give me a negative value. Let's choose maybe 0. That's an easy value to substitute in for negative 2 to 4. And again, 0 minus 4 is going to be negative 4. So I have another negative value. We knew there was not going to be a sign change because we already recognized that with that even power, it's just going to touch. So I'm just going to touch the x-axis, so I won't actually have a sign change there. And then after 4, let's choose maybe 5 as my test value. So 5, if I substitute that in, 5 minus 4 is 1. I am going to have a sign change because I cut through the x-axis here. So it makes sense that I come out to have a positive y value. Okay, so my function is positive or above the x-axis. So if you just think about what this really means, I have a negative y value, and then I touch the graph at negative 2, but I continue to have a negative y value. So that means I basically have a maximum right there at negative 2. And then my curve is supposed to cut the x-axis, so I have a positive y value after 4. And remember, at 4, I equal 0. So I'm going to have to touch the x-axis at 4, touch the x-axis at negative 2 because I equal 0 there, since I set my equation, my factors equal to 0, and my equation equal to 0. So those are my x-intercepts, and then I'll continue. And there's nothing else that we found, so there won't be any more maxes or mins. because we would have found it in our working. So a very rough sketch of our graph would be at -2, I have a relative maximum, and then at 4, I cut the x-axis, and I'll continue upward to infinity, okay? Now this is just a rough sketch. That's the whole point of using sign diagrams. It gives us an idea, a little more accurate idea of what our graph actually looks like. So for this one, we have a pretty good idea. If I wanted to be even more accurate, I'd probably try to find this minimum here. But again, I've got a really good idea of what my graph actually looks like. Go ahead and pause your video here and see if you guys can set up your sign diagrams for these two examples. So if you found the correct x-intercepts and then tested a test value, substitute the test value back in, you'll notice that both of these sign diagrams should alternate because your powers are all odd. So I don't have any even powers here, so I won't have a bounce occur or a double root occur. Go ahead and try this third one on your own as well. This one will have to be factored first and then set up your sign diagram. Notice for this last example, if you set it equal to 0, you can divide out the negative sign, and we have a perfect square. So x plus 3 quantity squared equals 0. So our x value will happen, well, our x-intercept will occur at -3. And then your test value should show the same sign because you have an even power for this function. Our last example today is going to include an asymptote. So you have a rational function with a numerator and denominator. Remember, our x-intercepts occur when your y value is equal to 0. And remember, your vertical asymptotes occur when you have undefined values. So that is when your denominator is equal to 0. So let's go ahead and set our function equal to 0. Since these are functions right now that are equal to y, right? Your input is x, your output is y. So if we set our function equal to 0, you're going to wind up multiplying out your denominator. Since in order for a fraction to equal 0, the numerator must equal 0. So if I set my numerator equal to 0, then my x value will wind up being +1/4. If I set my denominator equal to 0 to find my vertical asymptote, I'll set 2 minus x equal to 0, which would then imply that x is equal to 2. Putting all this information on my sign diagram, I have a solid line at x equals 2, and I'm going to use a dotted line, oops, other way around. We have a solid line, excuse me, at x equals 1/4, because that's my x-intercept, and let's use a dotted line for our vertical asymptote at 2. So already we have an idea of what our graph is going to look like. I'm just going to put this information now on my graph. So let's give ourselves some intervals here. Let's make these all equal to 1. So if this is 1/4 will be about here. And then we've got our vertical asymptote at 2. All right, and let's go ahead and substitute in some test values. So let's choose some values below 1/4, between 1/4 and 2, and then after 2 to see what happens for our function as in terms of it being positive or negative. So remember, when making your sign diagram, you're choosing test values and substituting them in to your original equation. So we had to substitute our test values back into that original equation to see whether our y value was going to be positive or negative. So right now I have a very rough idea of what this graph looks like. The only item we have not talked about yet is our horizontal asymptote. So it's a little hard to graph exactly, accurately when we don't have that horizontal asymptote graphed. So right now we know that we're below the x-axis before this 1/4 mark, and then we're above the x-axis after the 1/4. So that means I'm going to be below before 1/4 and above, approaching the asymptote after 1/4. And then I'm going to be below the x-axis after this too. So I'll be, if you think about how rational functions react, they act opposite to each other. So we probably have some kind of horizontal asymptote in here. We just haven't found it quite yet. And we'll talk more about that in the coming days. So we have a rough sketch, and this would have been our accurate sketch if we had included the horizontal asymptote. So we're pretty close. We're getting warmer, but the sign diagram really helps us figure out how the graph is behaving so that we can learn a little bit more about our function and start to graph more accurately. All right? Go ahead and review your notes, and we'll see you guys next time.